Good afternoon, everybody. Welcome to the webinar today. My name is Lauren Cooper. I lead the Forest, Carbon, and Climate program at Michigan State University, and I'm really delighted to welcome you to the last session of the 2019-2020 Forest Climate Working Group Learning Exchange Series. It's been a pleasure hosting the entire academic year's worth of webinars, monthly webinars, and we're really pleased to come to the last session today. So thank you so much for joining throughout the year. For those that don't know, the Forest Climate Working Group is a diverse group of forest interests with over 50 members, including landowners, industry actors, conservationists, academia, and those active with carbon markets. This group has worked together for more than a decade to advocate for state and federal policies that work to ensure sustainable forest use and prevention of land use change. To get to today's speaker, I'd like to introduce Mark Wishnie, Executive Director at PTG, Pactual Timberland Investment Group. Today, Mark will be sharing with us information about how new wood products like mass timber offer the potential to dramatically reduce the emissions associated with core industrial activities, including building and construction, while storing carbon in end products. But before we hand it over to Mark, let's cover a couple of housekeeping details. In case you are not on our mailing list yet, if you'd like to receive any automatic information about registration details and upcoming webinars, because we are planning the 2020-2021 sessions now, please reach out to us at forestc@msu.edu to join our email list. Attendees today are qualified to receive one continuing education credit from SAF if that's relevant to you. So this will be automatically communicated with your email address to SAF. So if that's something that you keep track of, that will be communicated automatically. But if you have any questions, feel free to reach out to us again at forestc@msu.edu. This session is being recorded and will be posted to the web along with any supplemental resources such as the presentation slides in the next week or so. So if you've registered, you'll receive an email letting you know when that is up and where to find it. And also just a quick note that all of the previous sessions are also recorded and available on our website. So when you see that full line of, if there's topics that are of interest to you, we do encourage you to go back and take a look. We've had some really excellent speakers. A quick note here on the Q&A. You'll see here there's a chat feature. And so when you're on Zoom, your menu bar can disappear on you a little bit. Sometimes you have to hover your mouse around on the screen and your menu bar will pop up. You'll see the word chat with a little drop-down triangle next to it. And here you can offer up questions at any point. So we do encourage you to, if a question pops up, feel free to send it to us. It's helpful for us to kind of keep track of questions as they're rolling in. You can save them for the end. We will have a Q&A. But if you have questions as they pop up, feel free to submit them at any point. We do often get a few folks joining in by phone and just listening in. So if you are on phone, but you can email, you can also send your questions to forestc@msu.edu. And in the case of outstanding questions, we will work with the speaker to have these addressed and answered in a document. I will note that we do have a large audience today, and so we may have some limitations in terms of answering all questions. So just to let you know about that up front. And I think that's all the background details. So with that, Mark, if you're ready, could you please take the screen and begin today's presentation?
Yes, thank you very much, Lauren. Let's see. Hopefully everyone can see my screen now. So first, I just want to say thank you to Lauren and Michigan State University and the Forest Climate Working Group for the invitation to speak today. It's a real pleasure to be able to talk with you all. I thought I would start by just giving a bit about my background and then dive into the topic at hand. So I'm a forester by background and by training. I worked as a research scientist for a number of years and have spent most of my career doing private investment in forests, and I currently lead sustainability and a climate-focused investment practice at the BTG Pactual Timberland Investment Group. I'm have just returned to BTG after a 3-year sabbatical, so to speak, where I led the Forestry and Wood Products program for the Nature Conservancy. And so you'll see some references through this presentation to some of the work that was initiated in the Nature Conservancy that continues. One other note, I'll be going through this material, I think, fairly quickly, and is a lot of complexity and nuance, of course, and a lot of detail in what I'll be touching on. I won't have a chance to go into all of it in the presentation, but hopefully the Q&A will allow for that. And one final note, the title of the talk refers to global outlook, and I will touch a bit on some of the global implications of wood product utilization, but just given time constraints, most of my comments will focus on the US. So with that, I don't imagine I need to spend a lot of time convincing this group of attendees that climate change is a significant issue, but I do think it's worth sort of level setting at the start of this talk by reminding us all that climate change is, in my view, and even given everything in the world today, still the world's most urgent challenge. And although there is a lot of effort and a lot of initiatives directed at addressing climate change, all the science tells us that we are well on track to blow past any safe limit on climate and to blow past the targets of the Paris Agreement. And if anything, the science is telling us that we are approaching tipping points and the most severe consequences of climate change much more rapidly than we even anticipated. And that is all just to say that this challenge is urgent. The scale that responding to this challenge requires we act on is a scale that really exceeds the scale at which any individual actors have been successful at affecting change to date. And so I say all of that just to emphasize or remind us all the seriousness of the work of addressing this global challenge. Of course, the challenge is great, but there are encouraging signs in that the commitments to climate action from governments, from corporations, from other actors have been increasing. And although some nations like the United States have withdrawn sort of national climate leadership, subnational governments, corporations have stepped into that fold. There are still 189 countries committed to achieving the Paris Agreement, limiting global warming to 2 degrees Celsius. Nearly a quarter of the global Fortune 500 have committed to reduce or eliminate emissions by 2030. So resources and commitments are growing, and there are real resources and commitments available to meet the challenge, but the gap between those commitments and action remains great. And it's in that context, I think, that over the last 2 years or 3 years, increasing attention is focused on natural climate solutions or nature-based solutions, the role that better management of land, of forests, grasslands, and wetlands can play in providing climate mitigation and achieving the goals of the Paris Agreement. And this graph is showing the results of a study from 2017. There have been a number of subsequent studies that have drawn roughly similar conclusions. The point here, there are a couple of points I think to draw from this analysis. The first is the top line conclusion that at some measure of economic efficiency, natural climate solutions can potentially provide perhaps a third of the mitigation required to achieve the Paris Agreement, and that's a very encouraging conclusion. The second lesson I think that this analysis or this research shows is that forests are really the majority of that opportunity, maybe 3/4 in this analysis of the total natural climate solutions potential. And really reforestation, that top bar, is the single biggest pathway for delivering climate mitigation, which is, I think, in part why it has received so much attention. So if we don't get the way that we manage our forests right, we really don't have much hope of leveraging the potential of natural climate solutions to be part of the answer. But the sobering part of this analysis is that the scale of action that's required to deliver on this potential is massive. So on that top bar, that reforestation bar, just that green portion, the bottom portion of that bar, achieving that would require 500 million acres of reforestation, new forest established over the next 10 years. And that's roughly equal to doubling the area of timberland in the United States in 10 years. A truly massive challenge. And so again, the scale of climate requires that we look at for solutions that are of commensurate scale, and really, unfortunately, solutions that are small scale in nature probably aren't solutions at all. So this analysis really is sort of a supply side analysis. It focuses on having more trees, more wetlands, more grasslands out in the landscape. But the scale of the challenge and the scale of the resources required to deliver on natural climate solutions, I think that is probably what drives a lot of us to think about the role of demand-led climate strategies, or the role of markets and demand for products in helping to deliver on some of this potential. So when we think about where there are resources that might help pay for the work required to deliver 500 million acres of reforestation or other significant NCS outcomes, one of the first places I think that many of us think or look to are forest carbon offset markets. Globally, and this is combined data from 2018 and 2019, but forest carbon offset markets globally were roughly 500 million in 2018, 2019. Another potential source of resources is government funding, and the rest of these numbers will be for the US. The US Forest Service budget in 2019 was $6.1 billion. There's obviously more government funding that goes to forests. There's state budgets, there are other agencies, but just as sort of a proxy. Philanthropy, environmental philanthropy in the US was nearly 13 billion in 2019. Of course, that includes support for wildlife, for animal shelters, for all kinds of activities. I don't know what portion of that went to forests specifically, perhaps 2 or 3 billion. Then the U.S. forest products industry, the value of timber sales and forest product sales in the U.S. in 2019 was 366 billion. So I make this comparison not to suggest that we can somehow turn all the economic activity in the forest sector as it is to suddenly deliver new and additional natural climate solutions outcomes. But I think that if we're looking for where there are resources that are a scale large enough to potentially drive changes in the landscapes we care about at a scale that makes a difference, it's hard to escape the need to look to the real economy in the private sector. And that then, again, I think leads us to think about the role of markets and products. There's another reason that looking at products, forest products as a climate solution makes some sense. And that is that as a forester, many of my colleagues and many of my colleagues in the environment community, when we think about climate mitigation in forests, we think about sequestration in the forest itself. We think about forest carbon stocks in all growth forests. We think about growing trees sequestering more carbon out of the atmosphere. But we know that when we harvest the right kinds of products, we manage forests in the right ways, we harvest the right kinds of products, and we use them in the right kinds of applications, we can have many more impacts on climate than just the sequestration in the forest. And I'll talk about these in a little bit of detail in the next 2 slides, because it is these different domains, these different impacts of forest products on climate that I think create a lot of confusion and concern. And we need to find better ways to understand these impacts if we're going to potentially make use of them. So this is an example, and this is just an illustrative example. The data I had at hand was from Brazil, actually. So this is showing forest carbon stock over time in a hypothetical stand of trees. In this case, these are trees that are growing on a short rotation, a 18 to 20 year rotation between planting and harvest. If we were working in the United States Southeast, if we were looking at an example from the Southeast, a rotation of 28 to 30 years might be more appropriate. In the Northwest, maybe 40 to 50 years, but the pattern would be similar. And so I'm showing this just for illustrative purposes. But this is showing a stand of trees over time and the carbon stock or the carbon impacts that accrue. So the bottom yellow layer, that's some natural forest on this property, which is maintained and which is sequestering a little bit more carbon each year. And then that bottom dark green layer, that wave pattern, that's rotational clear-cut forestry. So that's showing trees getting planted, trees growing over time, and then when they reach maturity, they're clear-cut. The carbon stock of that stand of the tree farm drops down to effectively 0, and then the trees are replanted and they grow again. And so that's that bottom wave pattern. In this case, based on this particular example, about 40% of the volume that's harvested from that stand is appropriate for use in solid wood products. The logs are big enough that you can make doors, windows, tables, etc. from the wood. So that 40% then is showing up in that middle green layer. That's stored carbon. That's carbon that goes into final products and stays in those products for as long as those products are in use. In this case, we just assumed the IPCC standard 30-year half-life for stored carbon in solid wood products. And then that top light green layer, that's the substitution benefit. And so what this is is a comparison between the emissions associated with manufacturing a wood product versus its alternative. So in the case of a wood product, that means the emissions associated with maybe driving equipment out into the forest initially to plant trees and then going back to harvest them, transporting those trees to a mill, the energy and emissions associated with running that wood through the mill to generate a final product and then transporting it to wherever it's used. Those emissions associated with harvest, transportation, manufacturing are compared against the emissions associated with extracting, processing, and delivering alternative materials like concrete or steel. And generally speaking, it's not true in all cases, and I'll talk about that, but often wood products have a much lower emissions profile or a smaller emissions footprint than their alternative materials. And so in this case, again, we just took a published average, and that substitution benefit accrues over time. That's a permanent benefit because the emissions that you avoid by not using that other material are the same as the emissions you avoid by, say, generating a kilowatt hour of energy from a solar panel rather than from burning coal. Something that's not reflected here is the end of life. So the potential wood products often have high potential depending on the application for reuse, recycling, cascading uses at the end of life. And when those are taken full advantage of, those can really increase the climate benefit because you get to continue to use that product without having to remanufacture it, without having to incur any emissions along the way. So that's not taken into account in this graphic, but I just wanted to mention that potential. But in this case, in this example, and this is a positive example, an example where we're starting from bare land and planting trees and generating benefits every step down the stage. So when we have systems where we can generate benefits from all of these impacts, we can deliver potentially 2 to 3 times the climate benefit of just having the forest. So we need the forest, but when we take advantage of climate positive, forest positive opportunities to substitute for energy intensive, carbon intensive alternative materials, we can potentially have even greater benefits. So to talk about this in a little bit more detail, I just want to talk through each of these impacts for briefly and make sort of two points about them. The first is that, and I'll talk through on each of these, but the impacts of forest product utilization on forest carbon stock substitution, storage, et cetera, they're not always positive. They can be positive, neutral, or negative. So if forest product utilization, if demand for more wood products incentivizes someone to plant more trees, to reforest, then that is increasing forest carbon stock. And here we're really talking about both stock and new sequestration. Or if a forest product requires larger diameter timber and therefore trees are grown on longer rotations, that also tends to increase forest carbon stock. There might be a product which actually drives no net change in forest carbon stocks. It might be the need for that product or the demand might be addressed just by shifting management of existing stands, or it might drive shorter rotations but an increase in forests. There might be interacting effects that generate a neutral outcome for forest carbon stock, or it could drive negative outcomes for forest carbon stock by driving shorter rotations, by demanding a smaller diameter material, or by driving forest degradation through poor management practices, or in some limited cases, and they are limited, but I'll touch on those again towards the end, even driving deforestation. Similarly with storage, so the carbon stored in products, you may have no storage, so you can imagine harvesting timber and immediately using it to generate bioenergy. There's effectively no storage. The carbon in that wood is immediately emitted. So there may be no storage, or there may be storage, and that might be for short periods of time, for say 1 to 3 years. A piece of paper might be 100 years in a building or longer. But the period of time that carbon is stored and stable, then that contributes to climate benefit. Substitution, of course, can also be positive or negative. In many cases, forest products have lower emissions profiles than their alternatives, but not in all cases. And in some cases, we can certainly imagine products where there might be a very low emissions intensity alternative, and from an emissions perspective, we're much better off with that product than with the timber product. And then finally, at the end of life, as I mentioned, many wood products have a high potential for continued use for recycling, reuse, cascading uses, all of which at the end of life contribute additional climate benefit. But there may be no impact, and in a worst case scenario, if something is buried in a landfill, undergoes anaerobic decomposition, there's no methane capture, you can have degrading wood that's emitting methane, a very powerful greenhouse gas, to the atmosphere. So the two key points, though, the three key points that I want to make are, first, that for all of these domains, impacts can be positive or negative. So we really need to understand what the impacts are of a particular wood product and the marginal change in demand for that wood product across each of these domains to understand what the climate impact is. And we really, in order to understand the climate impact, we need to understand the impact across all of these domains, because they don't all necessarily go up or down in tandem. Something might be positive for forest carbon stock, but negative for substitution, or vice versa. And unfortunately, we don't have good tools right now to allow us to integrate these impacts across all of these domains. And different stakeholder groups tend to focus on particular domains. So many of my colleagues in the forestry communities and environmental communities tend to focus on forest carbon stocks and tend to pursue policies or initiatives that increase forest carbon stock, but without consideration necessarily for all the impacts downstream. My colleagues in the design and engineering and construction communities tend to focus on substitution emissions. That's the emissions that are captured in environmental product declarations, the standard form for disclosing environmental impacts of materials that are used to compare among material choices. And for those who have been following the embodied carbon discussions, generally the term embodied carbon is used to refer to the production emissions of a material, but only the production emissions of the material. It doesn't typically include consideration of stored carbon in the material or any other impacts. So when all these impacts are positive, the net impact for climate can be quite positive. But in order to really understand the net impact, we really need to look across all of these domains. So I'm going to focus the rest of my comments a little bit more specifically on mass timber in the United States as a bit of a case study. I'm not going to go into much more detail on substitution and storage and life cycle assessment. My colleague, Neil, did a great job, I think, last month in the last session, learning exchange session, discussing those impacts in more detail. But I did want to touch on why it seems to me that mass timber and wooden construction is a good entry point. It's a good first step to thinking about these broader questions of how climate positive forest product substitution might be part of a climate mitigation strategy. So the first is that remember a couple of slides back where I was comparing the size of carbon markets to philanthropy and government spending on forests to the size of the US forest industry. On the left there, that pie chart, those two circles are comparing the global forest industry to the global construction industry based on some different data, different way of quantifying, but the construction industry dwarfs the forest products industry. It's 14 or 15 times as large, so it's a huge industry. And construction occurs everywhere that there are people, essentially. So if we want to identify a sector which is truly large scale, and that has potentially global application, then the construction sector is certainly a sector to look at. And then on the right, this is showing the contribution of the construction sector to global CO2 emissions. This is from 2018. And the construction industry is generally, or the built environment, it generally it contributes about 40% of global CO2 emissions, more than the transportation sector. About 11% of that is the emissions associated with producing primarily concrete and steel. And the remainder is the emissions associated with operating buildings, energy consumption, heating, et cetera. There's some research to indicate that the mass timber may actually be helpful with regards to improving operational efficiency, but I haven't seen anything conclusive there yet. But the 11% of material emissions impact is something that mass timber potentially can help us to address. The other important note about the construction industry is that we are projected to double the global floor area over the next 30 years. That is, everything that we have built over the last 2,000 years, all of the floor area that exists today, we're going to build it again over the next 30 years, and we're going to need to rebuild a lot of what we already have. So it's a huge industry. with a huge emissions footprint and with a very steep growth trajectory. So anything we can do to provide additional tools to reduce the carbon impact, the carbon footprint of the construction industry is worth, I think, paying attention to. For those who don't know, mass timber, that term refers to a family of relatively recently developed engineered wood products. Cross-laminated timber, CLT, is one of them, which has been in the press a lot recently. But essentially, mass timber just refers to different ways that large pieces of wood, think of 2x6s and 2x8s, the dimensional lumber that you can buy at Home Depot, glued together and layered often in sort of perpendicular layers, so that you create a material which has greater structure, has equal strength to steel at a lighter weight, and that can be used for both beams and panels in construction. And this allows us to build tall buildings with wood. The International Building Code for 2021, which is the code that generally defines building practices in the United States, now allows tall buildings up to 18 stories in height. You still use some concrete and steel in the buildings for the foundation, maybe for elevator cores, but you can dramatically reduce the concrete and steel you use in a building when you build with mass timber. And you then begin to have impacts on storage and on forest sequestration and potentially on end of life. And that those impacts on storage and substitution were really the focus of Indra's presentation last month. So I'm going to focus more on the impact on forests. And I think that the immediate question that a demand-led strategy raises for many folks is demand for wood products good for forests? And I think that really the focus, the more precise question is, what is the impact of a marginal change in demand for forest products, or for particular forest products, on forests? And economists who study commodities, and certainly many forest economists, will tell you that the basic rule of supply and demand should apply. That is that as more of something is demanded by a market, then suppliers will take steps to produce more of it. So if more forest products are demanded, then people will harvest more wood and maybe grow more forests. And just as an example, sort of pulled from recent headlines, that chart is showing global production and consumption of liquid fuels, basically of oil, over the last 5 years and up until the first quarter of this year. And you can see the sharp drop off in consumption driven by the pandemic, and then the resulting drop in production. So in many markets, supply and demand holds. The question is, how do we understand that the impact of changes in demand, and particularly increases in demand, on forests? And so in order to answer that question, I think that first we need to recognize that forests conjures up lots of different ideas for all of us. So on the right, those are pictures of 4 different kinds of forests. And when we use the term forest, for some of us, we think of old growth redwoods in a national park. For some of us, we think of trees planted in rows in a plantation. But the impact of demand actually varies and quite a bit, and it depends on the product and the forest you're talking about. So the first thing to be mindful of is, and again, we're using mass timber as an example, and I'll touch on this a little bit further, but mass timber is a softwood product. It's made out of pine, spruce, fir, the same species that we use to make dimensional lumber, 2x4s in the US, and that we use to build single family houses from. And the reason for that is the same reason that we use those species for 2x4s and for light frame construction, is that softwood species, those softwood species have structural characteristics. They're light, they have long fibers, good breaking strength, and they're suitable for construction. And so that means that of these pictures on the right, the top left is a tropical forest, the upper right is a mixed hardwood forest in Michigan, the bottom right is a eucalyptus plantation in Brazil, and the bottom left is a pine plantation in the southeastern US. Of all these forests, the only forest that would be directly impacted by demand for mass timber is the bottom left, that pine forest. So when we're talking about impacts on forests, it's important to first be mindful of the forests that we're talking about. So looking more closely at the US, where does the wood and mass timber come from? So most of the wood that's harvested in the U.S. comes from private land. So almost 90% of U.S. timber harvest comes from private land. It does not come from national parks or protected areas. The national forest system, which was actually created at the turn of the last century in order to provide a sustained yield of timber for use in the United States, it was a strategic timber reserve, essentially. It used to provide a fair amount of timber in the United States, but it really does not any longer. And national forests are 19% of U.S. forest land, but just 4% of total harvest. And harvest declined on national forests by about 80% from the late 1980s. And that is largely due to policy changes resulting from the so-called timber wars in the Northwest and the fight over the spotted owl. So today, timber is primarily a private product in the United States. And because mass timber is made from softwood lumber, this means that it's coming from really primarily two regions in the US. So the Western US in dark green and the Southeastern US in light green. The green is primarily softwood, and the blue in this map is primarily hardwood. Of course, there's some mixture everywhere. But 63% of softwood lumber comes from the Southeast. So the Southeastern US is the timber basket of the US. That's where about 2/3 of the softwood lumber comes from. It's also where 71% of the planted forests in the US are. About 30% of softwood lumber comes from the Western US and Alaska. So this is a material coming from private land and from mostly or largely from planted forests in these two regions of the United States. So then the question is, well, what is the impact of harvest on forest carbon stock? And there are a couple of ways of looking at this, and I also want to spend a few minutes on this because I think that the ways that we ask this question are really relevant to the kinds of answers we come up with. And one idea that has a lot of sort of currency in current policy discussions and public debate is the idea of the carbon debt. And so the idea of the carbon debt is that when we harvest wood, we're always reducing the carbon stock in the place that we harvested. Almost by definition, we've gone into the forest and we've cut down trees and we've removed them from the forest. So this is taking the same data from my previous example. This is a single stand of 20-year-old trees. So they're mature, they're ready to harvest. And we go in and we harvest them. And so right after we harvest them, the carbon stock on that sand goes to zero. Now, even if we are generating these substitution and storage benefits that I referred to, the idea of the carbon debt is the following. It's that until that carbon impact, that carbon benefit recovers back to the level of the forest carbon stock before we harvested, where that red line is, we've incurred a carbon debt. And in this case, if you look at, if you consider substitution and storage in this example, it's about 5 years. If you only think about the carbon in the wood product, it's maybe 11 years. Or if your focus is just on the forest, you say, well, it's going to take 20 years before you're going to recover that carbon debt. So even if you're arguing that this is carbon neutral, the argument goes that we have a very critical deadline of trying to limit emissions between now and 2030. So even if you're carbon neutral or even carbon positive in the long term, if you're taking actions which are increasing atmospheric concentrations of greenhouse gases in the short term, even if they're good actions in the long term, we can't afford to pursue those now because we have to do everything we can to hit those near-term goals. So this is a stand level analysis, and there are, of course, other ways to look at it. One is, this is a stand of trees that was planted 20 years ago in this case. So the question is, do you start your accounting at the moment of harvest, or do you start your accounting at the time that the trees were planted? The person that planted those trees might say, well, no, there's not a carbon debt here. I planted these trees 20 years ago so I could harvest them now, and over the last 20 years, I've been accruing a carbon surplus. So there's a question of when you sort of start the clock. But I would say that this is an analysis that really makes sense just for a single stand of trees. And again, we're talking about truly large-scale challenges and large-scale responses. So, a second way to look at this, and this is how many sort of large forest companies in the US might look at this, and they say, well, I don't have one stand of trees, I have 20 stands of trees. And so you can imagine the graph on the right, just imagine that the y-axis is 20 times as high as the graph on the left. The idea here is that, let's say I have 20 parcels, each the same size, and I plant one a year. And after 20 years, the first parcel I planted is ready to harvest, and the last parcel I planted is just 1 year old. Well, I'm going to harvest and replant each year, so I'm always going to have that same mix of age classes across my landscape. So once I get to age 20, that yellow line is showing that then my carbon stock is neutral. I'm only harvesting each year the same amount that I'm growing. So my forest carbon stock is neutral, and now I'm generating these storage and carbon benefits every time I harvest, and so that's all positive. So there's no carbon debt because I'm not just managing one stand. I actually planted all of this so that I can manage the production of the forest as a whole, and this is the right way to look at it. Well, I think that because we're talking about demand-led strategies, the reality is that markets don't look at individual landowners, whether it's a small landowner with one patch of trees or a large company with large areas to manage. Markets look across much broader regions. And so this map on the left, this is sort of the view of the world if you're a lumber mill or a pulp mill. This is a heat map showing mill density in the southeastern United States. Mills draw from areas within a certain radius, if they can, of their mill site. Transportation is a very strong limitation on the profitability of forest investments. So mills draw in defined regions, and they don't care whether they're buying from many different landowners or small landowners and large companies, state forests, municipal forests. They're looking to generate a steady supply of harvest to supply their mill and their markets. And I think that this is getting closer to the perspective that we really want to apply, because it doesn't matter so much if one particular patch of ground is being harvested. What matters to us is what is the net impact overall on climate? What is the net impact on the forest carbon stock in this market basket in this region, and really ultimately globally? And what is the net impact on substitution, storage, and end of life? And so, just to give one other perspective on this, this is the timberland area and stock of the U.S. Southeast over the last 64 years. This is from U.S. Forest Service FIA data, and what it shows is that timberland area in the dark green has been essentially stable. It declined a bit to the late 1980s and then increased a bit since. But forest stock, the volume of wood, the volume of trees that are growing on that landscape has significantly increased, and that's a combination of investment in faster growing trees. That's in some cases conversion of natural longleaf pine stands to faster growing loblolly pine stands, and there's some element there of carbon fertilization as well. That is, that with increasing concentrations of CO2 in the atmosphere, trees grow faster because respiration is more efficient. But the net, we can say that at the level of the region as a whole, forest area has been stable and forest growth has been increasing. So forest carbon stock has been increasing steadily over an extended period of time. And a recent consultant assessment of the U.S. Southeast, a deeper dive into this information, found a strong positive correlation between acres of forest inventory or forest stock, and growth rates, and found that markets, essentially removals, harvests, explain 65 to 90% of the variance in these variables, drawing a connection between demand for forest products and the area and the stock of forests in that region. And that makes some sense, particularly in a place like the U.S. Southeast, where many of these forests are planted in old cotton fields, on old agricultural land that was converted to forests because it was a better economic option for landowners. So you would expect forests that have been established in response to economic conditions to demonstrate this kind of a relationship. One other way to think about the impact of mass timber on forests, now at a national level, is to think about the relationship between construction and forests. So if you were in the forest business, in the timberland business in the US, anywhere that grows softwoods, housing starts are the number one variable that you pay attention to. Housing, new housing and remodeling is about 60% of US softwood lumber consumption. It's the single biggest component of softwood lumber consumption. So it is the thing that more than anything else drives how much you can sell and what price you get for what you sell. So on the left, that graph is showing in the green line housing starts, and in the yellow line, area of timberland planted. And this is over 35 years. And you can see a general relationship, not a perfect relationship, but a general relationship between harvest, as indicated by housing starts consuming more timber, and planting. And that's because in some parts of the country, particularly in the West, regeneration after harvest, not necessarily by planting, but regeneration after harvest is required under forest practices regulation or best management practices. In most of the US, because this product is coming from forests that were planted to produce this product, that planting continues post-harvest because people are staying in that business. And on the right-hand side, that's the same graph as the graph I showed on the previous slide for the US Southeast, but for the US as a whole. And it actually holds for each of the major regions that the Forest Service covers. Timberland acres have been steady or slightly increasing. Growing stock has been increasing steadily across the nation as a whole. So there's been significant demand for products, and we have not seen a decline in either forest carbon stock or forest area. One other thing that I would like to point out is that housing, as I mentioned, is the single biggest driver of sort of business performance for a lot of forest growers in the US. And there's a concern about whether increased rates of penetration of mass timber would dramatically change that and change these dynamics. I'll touch on it at the end. There's some research underway that's trying to answer this question more precisely. My guess is, and I can't be held to this, but just to throw it out there, my guess is that at really high levels of penetration, mass timber really took off, and that's sort of all we started building our mid-rise buildings out of. It might drive an increase in demand by say 10% for softwood lumber. I would just point out that housing starts, this is a extremely volatile market. So you can see that over recent periods of time, in the 6 years to 2015, the housing starts increased by 100%. In the 4 years before that, they dropped by nearly 75%, by 3/4. In the 14 years before that, they doubled. So this is a very volatile market, which has seen huge swings in demand, and mass timber might just cushion that demand by increasing it 10%. So it would be additional at the very upper end, but cushion it at the lower end. This doesn't suggest that a 10% change in demand, at least in my mind, would dramatically change these markets given how they performed with this historical pattern. Again, that's an idea which is being tested more carefully now, but just an observation to share. So what gaps do we need to fill? So I think that there are at least two key gaps that we need to fill. The first is that we need to have a much better understanding of what marginal changes in demand for forest products mean across these domains. I've just laid out a case that says essentially the U.S., which is a place which has good, generally speaking, good governance, good rule of law, enforceable contracts, a high degree of transparency, et cetera, that in the case of the United States, markets have responded to demand for softwood lumber by producing more of it without, there are of course places where there is degradation, there's places where there's fragmentation, largely driven by other forces, but they've delivered the supplies without reducing area or volume. But if we start to think about changes at big scales, at scales that really make a difference for climate, even if the mass timber takes off in the US and all of the wood that we supply for that mass timber in the US comes from sustainably managed forests where we know the provenance, there is still the potential that demand will displace demand that the US is supplying other places. And that as demand takes off in other parts of the world, that it will begin to affect trade in forest products. Because generally speaking, and this is not of course always the case, but generally speaking, log markets are local. That is, timber producers typically sell to mills within 60 to 150, 200 miles of where they're located. Of course, not for all species, but for softwood, I would say that's generally true. But product markets are global. And so if supplies of US timber that used to generate products that were being shipped to Asia or to Europe are now being consumed domestically, there may be other suppliers around the world that come online, and the impacts of that management may vary. For example, may be the case that an increase in softwood supply to Asia from New Zealand would be generally have sort of a similar result or a similar pattern as to what I showed earlier in the US, that generally you have replanting after harvest and good controls and oversight and transparency, et cetera. But if increased softwood starts coming out of the Russian Far East, where there's much more limited rule of law and governance and oversight, we might have very different consequences. And so there is a research study that was initiated by the Nature Conservancy that's underway now and has currently there are more than 24 researchers on 4 continents collaborating to try and look at what increased demand for mass timber in key markets around the world in the US, Europe, China, and the southern cone of South America might mean for impacts on emissions and storage in the built environment, but also what that would mean for regional demand for forest products, what those changes in demand might mean for global trade in forest products, both directly and indirectly. So what trade flows might meet that demand and what other trade flows might be displaced. And then finally, to look at what the impact of those changes in trade patterns might mean for the forests that are ultimately affected by them, so that we can really at a global level start to try to connect changes in demand to impacts on forests, both the carbon stock impacts, and I have not really touched on this because of time constraints, but impacts on all the other values that we derive from forests. So that is one study that's underway and I think will be an important contribution. Second is an initiative that being led by European Institute of Technology and Innovation, Climate Kick program, the World Resources Institute, the Nature Conservancy, and a number of collaborators, which is attempting to build a decision-making tool that can lay across those domains that I've talked about to allow decision makers to integrate, say, land use decisions on climate by looking at how land use decisions might have cascading effects down through markets to the materials that are used, carbon that's stored in end uses, and also to enable policymakers who are looking at incentivizing different material choices to look back and try and anticipate what those decisions might have, the consequences of those decisions for forest landscapes as well. So I think that these are just 2 initiatives out of many, but 2 that I think will hopefully make a useful contribution to this discussion, and start to chart a path forward that will allow us to try and leverage the potential of wood products to help address climate. Now, when we think about, and I've just 2 slides to wrap up. So when we think about what are the barriers to greater climate positive wood product utilization, I think that there are 2 at least. One of them is what I've just touched on, which is knowledge. That is, we need better tools to let us know when wood product utilization is climate positive and when it's not. And we don't have great tools to allow us to do that now. So I think, and I'll touch on this in the end, I think we need to apply a sort of a precautionary principle to how we move forward. But I think that the second barrier is really one of social license, of perception and of social license. So this is, I'm showing you here the results of a stakeholder survey completed by the North American Forest Partnership in 2017, 1,300 environmentally aware adults, 300 in Canada, 1,000 in the US. They were asked a whole series of questions, one of which was, which of these is the most renewable material? And when given the choice between wood, plastic, steel, and concrete, nearly 4 out of 5 identified wood as the most renewable material, which is a very sort of positive view of the environmental performance of the product. However, when those same respondents were asked which of these phrases describes the forest sector, the industry that produces wood, less than 1 in 5 I associated the terms environmentally responsible, sustainable, socially responsible, innovative, responsible stewards with the sector. So this is what I think of as the social license gap. So whether that perception is deserved or not deserved, let's set that aside for a moment, or it's an important question, but irrespective of that question, which needs to be answered affirmatively, the perception of the industry that produces this material as a bad actor is, I think, a significant barrier to aggressive action to drive climate positive substitution of forest products into sectors of the economy where that can make a difference. And that's because if the general public doesn't see the industry that produces this product as being deserving of the prioritization that would need to follow, then it's very difficult to see how significant action can occur. So I think that this is a sort of a significant barrier, which requires both science, knowledge, information, and communication. Then just to wrap up, final slide. So given all this, and given the urgency of the challenge and the scale of the challenge, that we have unknowns, we have really important questions that we need to answer. We need to make sure that we're not taking actions that actually drive perverse outcomes and make matters worse. So a question is, what should we do next, and how can we take positive actions now? So I think there are really three things that we can pursue now. The first is, I think we need to dedicate significant effort and resources to developing the tools that allow us to integrate analysis across these different domains, so that we have transparent, robust methods for really understanding the climate impacts of material use decisions and land use decisions. The second is, I think that the forest industry can take tangible positive actions to earn greater social license, to prepare the way for the industry to contribute in a much more significant way to climate mitigation, which I think, however we achieve the promise of natural climate solutions, the commercial use of forests and private forests need to play a significant role. And so I think that needs to happen in any case. And then the third is, I think that we can take some aggressive actions now to favor, for example, wood in construction, if we apply some precautionary principles that can be perhaps weakened or reevaluated. Weakened is probably not the right word, but reevaluated and made more discriminating as we have more information. I think the first is that if there is some initiative which would favor wood in construction, it should favor wood that is sourced from sustainably managed forests. And I've laid out some of the standards, or the sort of the principles that would apply to definitions of sustainability. This is not an exhaustive list. Most certification standards consider these criteria. I would just note that there are many forests. Most of the forests in the United States are not certified, and many of them are sustainably managed. So there are always going to be challenges in adopting that. But again, as a precautionary principle, I think if there's going to be some benefit using the accrues to using wood in a climate positive application, I think we can set a standard that it has to come from a sustainably managed forest to enjoy that benefit. And then the second is that I think we can apply a principle that it needs to come from a wood basket, a wood basin, whether it's a region or a wood basket is defined around a set of mills, where that basket has stable or increasing forest area and carbon stock. If it doesn't have a stable area, forest area, or carbon stock, then that wood just wouldn't enjoy whatever that extra benefit is that it's encouraging its use. And that would, I think, protect against some of the worst negative outcomes until we have tools that allow us to really better refine our estimate of changes in demand on forest carbon along with the other domains. So I'm over time, but I think we have a few minutes left for questions, so I'll pause there.
So Mark, thank you so much. This was a really interesting overview. You've covered a range of topics and kind of woven them together in a really interesting way that I think is a really nice kind of capstone to a lot of the topics that we've been discussing throughout the webinar series. So to kind of jump right into a couple questions, since we don't have a lot of time, I have kind of two questions here that are related. And one's, it's kind of into the land use change component. So you pointed out that one of the concerns, of course, would be negative landscape impacts, and you've provided some data that shows that that's not what the data shows in the United States. And you mentioned that one of the tenets, though, could be no conversion of forest type. So we're wondering if you could unpack that a little bit more. Like, are there assurances about the conversion, assurances protecting against a conversion of forest type? And for example, in your carbon debt analysis, do you associate do you have space for a past land use, in a previous land use in that kind of carbon debt analysis? Where do you get that kind of information? How can you assure that that's not occurring?
Yeah, good questions. And I think that something that is unfortunately in some of the public debate about forest use and the roles that working forests can play in addressing climate change. The debate unfortunately often focuses on whether we should just protect forests or whether we should manage them. I think what I'm trying to convey here is that I think the path forward is that we should be pursuing both management and safeguards together. And so what those safeguards look like will vary from place to place. And I've tried to lay out some general principles here rather than something too specific, because they will really depend. But in this case, what I'm suggesting is, let's imagine that there's a policy being developed in the United States that was going to favor wood in construction. And there have been some state and some federal policy proposals to that end. I would suggest that we have enough evidence to say, yes, we know that wood can decarbonize the construction sector. We should pursue policy, it makes a lot of sense to pursue policies like that. But if that policy is going to, say, provide a tax credit or some other financial incentive if you use wood in construction, I'd suggest that we should apply conditions to that say that you can only achieve that credit or receive that benefit if the wood that you're using for your construction meets these additional criteria, is coming from a sustainably managed forest, and is coming from a basin with a stable or increasing forest carbon stock. So, in the context of the U.S., I think that might be a path forward. And these are some principles for further discussion and debate. But that would be sort of the safeguard. It's saying, under the business as usual scenario, that forest management will continue as it does in the United States. But if you're going to prioritize forest use in that application, what is prioritized is only forests that meet these criteria. Internationally, there's of course a whole other range of conditions and variables, and I'd be happy to talk about those maybe in the follow-up Q&A.
Yeah, so thank you so much. So you just kind of touched on some incentives on the consumer side. So, incentives for the actual application of wood products. We have a question here about incentivizing conversion of land use to forest land. So if it's not current, so afforestation essentially. This participant pointed out that some landowners can be hesitant to commit to forested land use for a variety of reasons. Do you have any experience with this type of barrier or how that could be overcome?
Well, yes. I mean, I think it's a very important barrier, and I think that's the limitation that we see. And I think that there are two, that barrier is sort of two components. One is the sort of just sort of financial comparison. I have land which I could use for cotton, to grow cotton or to grow trees, and one financially performs better than the other. The second barrier has to do primarily, I think, in my experience, with time, and that is, if I'm growing an agricultural crop, I get income every year. But if I commit my land to forest, I'm committing for decades to have my land in trees, and I might not have revenue for an extended period of time. And so I think that in addition to creating the demand incentives, we need to also identify those are not the only barriers to afforestation or reforestation, conversion of previously forested land back to forest. There are barriers like the ones that the respondent is asking about. So I think that there are lots of ways to overcome those barriers. Again, they're very sort of site and location specific. There are subsidy programs in the U.S. and outside of the U.S. that pay some of the upfront costs of tree planting. And provide technical support so that you actually get some revenue early on. There are also, it is possible to create tax incentives, and you can sometimes generate tax benefit by converting your land use from one use to forest. You might get preferential tax treatment. And then, of course, there are carbon offset markets which can provide, in some cases, some relatively near-term payment for reforestation. But as I pointed out, those are still, unfortunately, relatively small in scale. I think carbon pricing and carbon offsets, if we can develop more robust systems in the U.S., might also help to overcome those initial barriers to reforestation.
Thank you so much. And I will mention to everyone, I'm getting some really wonderful questions. So I'm going to just do two more right now, and then we're going to circle back around with Mark to see about getting some additional insight on some of these other questions. So just two more questions. So we will go over just a couple of minutes today, but it is our last session, so we'll bend the rules. One question here is, where does the use of forest bioenergy fit into the 3S framework?
Yeah, great question. So, and bioenergy is, of course, one of the most controversial uses of wood. That's another reason to maybe start with mass timber as an entry point into this discussion. So, bioenergy, it has impacts on forest carbon stock, and it has impacts on substitution. Bioenergy, generally speaking, does not have any impact on storage because generally wood is burned relatively quickly after harvest, and so one typically assumes that it's immediately emitted. So what you're really looking at there are the impacts on forests and then the impacts on energy production. So at the energy production side, you tend to have sort of a very positive emissions comparison on substitution. So transportation and emissions associated with production tend to be much higher for, say, coal or oil. Many many researchers have pointed out that that's true, but the calorific content of, say, coal tends to be much higher than wood pellets. So you end up burning more pellets than you do coal for the same amount of energy. So you end up emitting more carbon. And so then the question really becomes a question of carbon debt. And that is that initial question of what is the impact of biomass energy on forest carbon stock, and are you harvesting more or less than you're growing? And so that, I think, for biomass energy, maybe more than any other, if you're looking at biomass energy in isolation, you really need to be able to look at that whole cycle. And there's biomass energy which is carbon positive in the near term and carbon negative in the near term, right? And not all applications are positive. So it really impacts those two domains, and perhaps more than any other, I think being able to integrate those two domains is really important. The other thing that I'd say about bioenergy is that we use that term very generally, but bioenergy means lots of different things. So for many of us, we think of pellets being manufactured in the Southeast and shipped to Europe as bioenergy. But in fact, in the US, and I haven't seen a good number that breaks this down, but an awful lot of bioenergy is generated, for example, at a sawmill, where a sawmill takes logs and converts them to wood, and all of the sawdust and chips and bark that are removed and don't end up in those 2x4s are put into boilers and produce energy or produce heat to help run the mill. And so a lot of bioenergy is actually sort of locally used, is not transported across oceans, and is really it's really use of a waste product which otherwise would go to landfill and emit methane or carbon. So again, the use case really matters for bioenergy. When you're dealing with short-lived wood products, and bioenergy is the shortest of them, I would say, the use case, the specifics of what you're using it for and what you're replacing really matter in terms of whether the carbon balance, the climate balance comes out positive or negative.
That's really helpful. Thank you so much. So your last question here is kind of a bigger picture question that is looking at for forest lands that are working forests, so managed from kind of a business perspective. If they were to really start prioritizing and optimizing carbon sequestration, how would management and overall operations change? Do you have a sense of how hard that would be, and are there big barriers that would need to be overcome?
That's a great question, and I feel like this is my answer on all these questions, which I apologize for. But of course, it depends. I mean, so the question is, if you're gonna prioritize forest carbon, then at sort of the extreme, what you would do is you would essentially stop all harvest except any harvest that you need to be able to keep the forest healthy and growing, right? And eventually, you would get to a point where you would expect forest carbon stock to be relatively stable. There's some cases where forests, even mature forests, are continuing to grow, perhaps because of climate change. And really disturbingly, recent research which is finding that some critical forests around the world, like in the Amazon basin, are actually starting to become net sources of carbon. They're becoming net emitters because the hypothesis is because of a changing climate. So there's another thing for us to think about with forest carbon is that forest carbon is unfortunately very rarely stable over time, no matter what the circumstance. So in the extreme, you would stop harvest, right? And then you'd have to come up with a scenario where you think about what that means for the economy as a whole and for all of the lands. In a more practical response, that conversation in the US tends to focus on two things. It tends to focus on extending rotations in places where you have a more intensively managed forest, like the Pacific Northwest and the Southeast. So instead of harvesting Douglas fir at age 45, growing them to 55 or 60, as an example. Or in the Northeast, it tends to refer to reducing volumes harvested from mixed hardwood forests where you're dealing with more natural forests and you're simply reducing removals. So the impact on forests in those two scenarios, and that's not the sum total of them, but those are, I think, the two that are most often talked about. It depends. For forest owners, of course, if you're going to suddenly defer income for another 15 years that you were counting on, that can have significant impacts. For mills, it can start to have impacts if that means you're starting to get larger diameter material, because mills are designed to efficiently process the particular sizes of logs, and that will begin to change if you're shifting the age class. So those are two things that you have to adapt to. There was one recent paper that Diaz et al. From University of Washington and EcoTrust published looking at the Pacific Northwest, and they were sort of answering this question. It was not quite this question, but it was included in the variables they looked at. And they looked at, if you extended rotations and you left more trees on the landscape, the outcome was more forest carbon, but a relatively significant decline in net present value, which is sort of the most fundamental or a fundamental estimate of financial value. So I think that in most cases, what you would find is that there's a transition period where there are some significant adjustments. There may be a reduction in value because most forests are being managed. They're being managed commercially, they're being managed to optimize at some level their financial performance. So any shift from that is going to become suboptimal. So I think that those would be the two consequences. It doesn't mean it's not possible, but those are the things that one would need to take account of in pursuing those outcomes.
That was really great explanation, Mark. And again, thank you so much for taking the time to answer these questions and going over just a few moments with us. We're going to take over the screen now and just remind folks that this webinar is being recorded. And so any supplemental materials will be posted within a few days. And so if you'd like to, if you've registered, you'll get a notice when that's available. And again, you can contact us at forestsea@msu.edu. And again, as you can see from the lineup, this was the last webinar of the 2019-2020 Learning Exchange Series. And a really sincere thank you to all of the speakers that participated in the lineup. Thank you again to Mark for today's really excellent presentation. We're currently in the process of planning the 2020-2021 series and look forward to announcing that full lineup soon. Please reach out if you have a nomination that you'd like to share. We'd love to hear from you as well. So again, thank you to our speaker today, to Mark Wishnie from BTG Pactual. And thank you for the time and thanks for joining us. I hope everyone has a great afternoon. Thanks again, Mark.